I'm going to take you through an example of drawing the ray diagram for a convex lens. We're going to draw 3 principal rays, and all of them we're going to show bending in the middle of the lens. Even though we know that the ray will bend once when it enters the lens, and again when it leaves the lens, it turns out that we can make a very, very good prediction of where that image will appear, even if we treat it as only bending in the center. So I'm going to draw all of these rays starting from the very top of my object, so right from the little smiley guy's head. The first one I'm going to draw goes parallel to the lens's axis, so it just goes straight across like that. Now, the focal point is by definition that spot where parallel rays are going to meet. The trick is I've got 2 focal points, one on either side of the mirror. I'm sorry, on either side of the lens. Since this is a convex lens, that means that it's trying to bring those rays that strike it closer together. So if I just try to visualize that, that tells me that I have to go through the focal point on that side of the lens. All right, the next ray I'm going to draw is essentially the reverse of the one I just did. I'm going to go through the focal point that I didn't use, in this case the one near the object. And I go down just to the center of the lens. And then this one goes horizontally. And then the third and final ray is going to go simply through the center of the lens. And this one is going to go straight through, so it's effectively entering either edge of the lens along a normal line, which causes it to go straight. Then I just look for where these 3 rays meet, and that is where my image appears.